So hello everyone, this is lecture 33 for the mathematical physics. In the last lecture we did the roots of the complex numbers and we already covered the polar form and all the introductory part. Now let's study in more in detail about the complex numbers. Today we will see about the derivative and the analytic functions. Okay, so first of all we will define the continuity and the limits just like we have for the real numbers. So we'll go from the basics, so don't worry about it. So let's see sets in complex plane. So there are kind of sets in the complex plane. We will study about them like circle and disc and half planes. So I will introduce all of them for you. So just like we have this mod z equal to 1. So what this denotes? This denotes the set of all z whose distance from center origin is 1. Okay, because mod z is nothing but under root x square plus y square, and we know from the polar coordinates and every time I defined you that this modulus represents the distance of that point in the complex plane from the origin. So if distance is 1 and you see that all the points which have distance 1 in the complex plane will make a circle. So that's why this is the equation of circle. Set of all z whose distance from center origin is 1. So mod z equal to 1 represents under x square plus y square equal to 1. So this is the modulus, and this equation is again the equation of circle. Now this is a special case when origin is at 0 0. Now we can define in general the circle, that is mod of z minus a equal to rho. This represents, this is our radius and this is our origin a. So this is the equation of circle again, whose radius is rho and origin is a. Set of all z whose distance z minus a from center is a is equal to rho. So this represents the circle. As you remember from the equation of circle, we know that x minus a plus y minus b equal to r square, means x minus a square plus y minus b square equal to r square represents that a and b are the origins and r is the radius. So same is here also. If you write it as x plus iota y and a is some x plus iota y, means a is something, then you will take the real parts and imaginary part, then you take the modulus, and that will again give you the form of same equation. So this a denotes the origin here. So this is our equation. Now see, if you want to find the equation of this circle, you will take any point x plus iota y, then you will minus this point, then this distance is equal to radius. So that's how you will get again this equation. So this represents a general form of circle. Okay, hope it is clear to you now. Now we define open circular disk and closed circular disk. Means when we consider all the points inside this circle, means not on this circle, inside this circle, means this circle is excluded. So all points inside this circle, then we call this as open circular disk, means this boundary is not considered. So interior of the circle z minus a equal to rho, that is z minus a less than rho. So distance of that point should always, means distance of that point from that origin, from this circle's origin, always center should be less than rho. Then we call those points as interior. Okay, and it is open circular disk. Now when we consider this circle also, include this all points on this point, then we'll call it as closed circular disk, and it will be represented as z minus a less than equal to rho. So now equal to sign is introduced when it was less than, that was open circular disk. So and this complex plane is always 2D, okay, because we have one imaginary and one real and one imaginary, always in a complex number. That's why this complex number is always in 2D plane. Now let's see some examples. Z minus iota. So iota, we can write this as 0 plus 1 iota. So it will be x plus iota y. So it will be x minus 0 plus y minus 1 iota. Okay. So it will be under root, means at y we have 1 and at x we have 0, that is our origin. So that's how you can find the value of a. So this will be our origin, and this will give you radius, because in this form you can compare. So 4 is radius, so this will be our origin, and this distance is 4, so coordinates will be 0 5, and this equation represents this circle. Now let's see one more example. z minus 1 plus iota equal to 1. So just compare with that equation, z minus a equal to rho. So a's are this, so origin at 1 1 and radius is 1. So it will be 1 1 and radius is 1. So this is our circle represented by this. Now you can use this form also. You can convert this in this form, means it will be x minus y plus y minus iota, y minus 1 iota. So modulus will be under root x minus square plus y minus square equal to 1. So this will give you 1 square again. So now you can see this is, you are familiar with this equation. This is the equation of circle, and from here you also can find the same value, that origin is 1 1 and radius is 1. So this equation is just same as this. Now let's introduce some more terms, that is open and closed annulus. So what are annular region? So if we have two circles like this one and this one, then this region included, means this region inside these two circles is called the annular region. Okay, and we have closed annulus and the open annulus. When it is closed annulus, then these two circles are also included, means all the points lying between these two circles and or on these two circles, okay, inside or on. But when it is open annulus, then all the points lying inside these two circles, not on these circles, then we call it open annulus. So z minus a, this point, and distance should be always between this rho 1 and rho 2. And from here in the closed annulus, this can be greater than, equal to, or less than equal to this. Okay. Now set of all z whose distance from center a, that is z minus a, is greater than rho 1 but less than rho 2. So that is open annulus. So I hope it is clear to you. Now let's see, some terms can be defined, means in the questions you will get these terms like half planes, lower half plane, right half plane. So you must know what are these, so you can solve the questions. So half planes, if I define to you, then upper half plane is nothing but it's like you take this coordinate system, and above this x-axis is all called upper half plane, and below this is called the lower half plane. Right side of y is called the right half plane, and left hand side is called the left half plane. Okay, so that's how you define this. Upper half plane, set of all z such that y greater than 0, y less than 0. Lower half, right half, x greater than 0, and left half, x less than 0. So remember these. Now let's see what are complex functions. So we have seen the real functions, where it is something kind like fx equal to something in the form of x, where x's are independent variable and fx is dependent variable on x, of course. So that's how we define the real functions. Now what is complex functions? So we know complex functions, we define the variable as z. So any function which is depending on z is called the complex function. Any function w z of complex variable z equal to x plus iota y is defined as complex function. This. Now wz, this function, complex function, can be written in this form. Again, in the real and the imaginary form, this function can also be written in this form. And these functions always will be the function of xy, because it is on the 2D. Okay. So uxy, vxy are real. So these are real, but iota represent this imaginary part. This is real part. They can be added, multiplied, or divided, just like complex number. Okay, functions can be added or multiplied. So we'll see some examples, it will be more clear to you then. So like we have fz equal to z square. So this function depending on z square, so this is a complex function. Now let's see, we can find u and v from this here also. Like in place of z, just put x plus iota y and expand it, you will get this. So this will be our real term and this will be our imaginary function. So this will be u, this will be v. So that's how you can find the u and v of any function, complex function. So function value, what is the function value? So fz is this. If fz is this, then we need to find u, v and f at z 1 plus 3 iota. So how you can find u and v? So first, z is defined as this. Let's say x plus iota y, compare, then x will be 1, y will be 3. So you can find it in any manner, like you can put it directly in this 1 plus 3 iota and you will find this. So this will be u minus 5 and y will be, u will be minus 5 and v will be 15. Now let's find in the another way, means put z equal to x plus iota y and find the uv first. So we will get u as this and v as this. Now we know the value of x and y, that is x is equal to y 1 and y equal to 3. So substitute it here in this u and v, and you will get again the same values as we find from here. U will be came out to -5 and v will be 15. So that's how you can verify, and you need to remember this thing. How are we doing this? So now let's take one more example. Fz equal to 2 iota z plus 6 z conjugate. Okay, now z is 1 by 2 plus 4 iota, this is given, so you can find it anyway. X is 1 upon 2, y is 4. So either you can directly put it here and first find the u and v, just like I did here. Z is this, so z conjugate will be this. Solve this, you will find 6. This is your u, this is your v. Now put x and y values, you will get u value will be -5 and v will be -23. Okay, so it is easy, just a simple maths. Now let's define a very interesting topic, that is limit of a function and continuity. So you already studied about the limit of a real function. Okay, what we studied there is that is if there is a point x0 and then all the values of f(x0) means nearby x0, any value x0 plus something, x0 minus something, all should tends to a fixed value. Okay, means they should be together, means a value should not differ. This f(x0) should not differ much. Then we will say that limit exists, and if they differ among them, then it will be limit will not be defined. So let's see. So it's just like same here also. A function fz is said to have limit L as z tends to z0, written as this equal to L, only when if f is defined in the neighborhood of z0 and if the values of f are close to L for all z close to z0. So if there is this z0 point, then all the values around it should tends to this z0, means f z0. Okay, now see z as we see that in the when we talk about the real functions, then we take the x as in on the one axis and we define x0 plus h, x0 minus h. But in this complex function we have a complex plane, not a single line. So here this function should be defined in a region, not a line. Okay, means on all points it's means if there is this point z0, let me tell you, then in this particular region from all directions all these points should be tends to this f z0. Okay, so only then we will call it as limit exists for z0. Means from all direction we have to check if all the points corresponding to this f z0. So hope you are getting this point. Just like in the real functions we have checked for the x-axis, means plus points, and the minus points they tending to this point. In complex plane we check in a region that they are tending to this point. So how we can check? Z tends to z0 from any direction in complex plane, and limit does not change, means limit should not change if we are tending to z0 from any direction in the complex plane. Then its limit exists, otherwise limit does not exist. Means limit should not change when we come to this point in any direction. From any direction limit should not change in the neighborhood of this region. If it changes, then limit does not exist at this point. So you will understand it more by an example. Let me give you an example. Let's we need to find this limit. Z tends to 0, real z square plus imaginary z square divided by z square. So let's say z is x plus iota y. So when you open this square, you will get real z square will be x square minus y square, and imaginary z square as 2xy, and z square is nothing but x square minus y square plus 2 iota xy. Okay, so this is your function. Now you need to check if limit exists or not. Now see, you need to check in all directions. So you can't do that because there are infinite directions. So you need to check only for the 3 values. Means first fix this one value on the x-axis and make this y tending to this point. Then fix this y point here and make this x point tending to this, and then take this value x equal to y, and then check this x tending to this point. Then if these values are come to be same, then we say that limit is defined, otherwise not. So let me tell you what I am talking about. If z tends to 0, means we need to check at 0. So let's say our point is here. Now first we will put y equal to 0. We fix this value. Now we'll check that x tending to this point, x tends to 0. Okay, so when y equal to 0 and x tends to 0, so we'll substitute y equal to 0 in this equation. You will get x square over x square, and this will be 1. So when y equal to 0 and x tends to 0, we'll get a limit as 1. Now let's fix this x value, x equal to 0. Now we will say that y tending to 0. So x equal to 0, so you will get minus y square divided by minus y square, you will get 1 again. So we'll say that it is 1. So it is defined in these two directions. Now we need to check for one more direction, that is this line, means x equal to y. So when x equal to y, just substitute in the place of x, y. So we'll get y square minus y square. So if you put x equal to y just, then it will be x square, you will cancel out. It will be 2x square and 2x square, so they will cancel out. We will get 1 upon iota, and 1 upon iota will give you minus iota. So when x equal to y means we have checked this line, and x tends to 0 or y tends to 0, they will be same here in this line. So we'll get the limit as minus iota. So it is not same as in these directions. So we say that limit is not defined for z tends to 0. So that's how you can check. You need to check for these three lines, okay, these three directions, and they should be same to limit exist. Now let's define continuity. So it's just very easy if you already understood the limit. A function fz is said to be continuous at z equal z naught if fz naught is defined and limit is same as fz naught. Means now limit should be equal to fz equal to 0, means they should be equal to this point, means whatever the value of the function at this point, that is fixed. Now limit should be equal to that point, then we say that the function is continuous in that region, in the neighborhood region. All these regions should give you the same value, that is fz naught. Not by definition of limit, fz is defined in the neighborhood of z naught. So that's how you can check if limit is defined or not. If fz is continuous in some region, then it must be continuous at all points in the region. So this was the continuity at one point. Now if we say that function is continuous in particular region, then it must be continuous in all the points, on all the points in that region. Then we say that this function is continuous in that region. Okay. So let's take one example. Check whether fz is continuous at z equal to 0 if f0 equal to 0. So the value of function at z equal to 0 is given. Now we need to check in the neighborhood if this came out to be same or not. If this came out to be same, then we call the function as continuous, otherwise it's not continuous. So for fz is not equal to 0, function is given this. So let's say imaginary z will be x plus iota y, so imaginary z will be y, and mod z is under root x square plus y square. So this is our complex function. Now let's check in all these three directions. So first put y equal to 0 and x tends to 0. So we'll get 0 because y is 0. So this is same as this. Let's check for the other direction. Means we will put x equal to 0 and y tends to 0. So when you put x equal to 0, then you will get y over under root y square. Under root y square will give you mod y, and this will be plus minus y. When y is greater than 0 and y less than 0, it will be minus 1. So see, these values are varying when 0 less than 0 and greater than 0. So here we are getting different values. So we'll say that function is not continuous definitely. We don't need to check the third line because it's already proven that it's not continuous. So we'll see this example in the next lecture. So today let's end today's lecture here. Thank you everyone.